All right, so the plan this week is to understand some intro to programming with Ruby. We'll talk about some of the basic data types such as integers and floating point numbers and strings, as well as variables and expressions and functions and basic control structures and predefined modules. And that's the plan for this week and beyond. And let's take a look at the Ruby interpreter. I think you have already all seen that. If you type into a shell IRB, it gives you an interactive Ruby instance, and you can type something in your computer and will process it. And these functions, if you have a function that needs to be loaded, if you have a pre-written program. Now, some of the basic things that you need to know in terms of programming are that the Ruby and many languages give you arithmetic expressions such as addition, subtraction, multiplication and division, as such as exponentiation and modulo operator, which starts with the remainder when something is divided by something else. And Ruby is like a calculator, so if you type an expression like this, it will follow the precedence of operators. It will multiply 3 times 5, then add 2 to it, and give you the answer 17. And then the expressions are essentially, you can think about the order of operator precedence. In other words, the exponentiation is done first, then the multiplication, division, and the modulo operator, then finally plus and minus. So that means when you have an expression, the Ruby will know which one needs to be done first. Like in this example, multiplication needs to go before the addition, and so on. But you can also use parentheses to force something to be done first. Like in this case, 6 plus 7 will be done first, and then multiplied by 5. The associativity important. For example, if you have 2 plus 3 plus 4, it'll be doing 2 plus 3 first, and then add 4 to it. So the associativity come from the left to right. And also for exponentiation, the associativity come from right to left. So in other words, it'll do 3 times 4, 3 to the power 4 first, and then it will raise that to the power 2 next. Now, data types that are important part of programming with any language. We get multiple types of data. We get integers, or we get floating point numbers with decimal points, and also strings that are indicated by quotations, and also booleans that are true or false. So those are the particular data types that you can use in your programming functions. That means it's much easier if you know what kind of data you're processing. That's very important for programmers. Now the division, note that if you write 7 divided by 2 in typical mathematics, you will get 3.5. But in Ruby, you will get 3. The reason is that it is integer division, so it drops the decimal part from it. I will go over some of those things later on. So if you have any decimal point, so if you divide 2 integers, you get an integer without the decimal remainder. So now, but if you have 2 floating point numbers, or even at least one of them floating point numbers, then you will get the actual results as 3.5. So keep that in mind. So this gives you sort of like the quotient when you divide 7 by 2, and this gives you the exact answer because it's precisely the 3.5. Now variables are really it's defined to be simply a place where you can store a value. That means a value that can change. So for instance, you can define a variable called a and put 5 into that thing, so that it's a place in the memory, someplace that you store it, and then it can be changed as you want. Now, for example, in this case, you have a equals 5 or b equals 2 times a. Since a is already stored, it's going to use the value of a, which is 5, multiply by 2, and give you 10, and store 10 at the location of b. Now, here's another example of a variable where you have associated a variable with a string woof, and then if you write, that's still stored as a string here. So strings are also locations in the memory. Obviously, string this needs at least 4 characters to store, and this may need, depending on the size of the data, we're not going into details there, but this stores an integer and this stores a string. Now, names of the variables must start with a lowercase. That's very important. Otherwise, Ruby will complain. The remainder of the variable name can consist of any combination of uppercase letters, lowercase letters, digits, and underscores. And Ruby is case sensitive. That's very important. That means this and this are not the same. So you have to be very careful about your case sensitive typing. Now, when you write your own method or function, so here's the syntax for doing that. You use the word define, the name of the function called tip, and the total is the argument to the function. So think of this as function f of x, where x is the total and f is the function name. And then what it does is to take the total and return total times 0.18. So it's sort of like it's computing the 18% tip for a total amount. So if you say tip 20, so if you spend $20, 18% of that would be 3.6, and so on. So this simple function can compute the tip given the total. So the syntax of the method or the function would be the method name that you can select. You choose that, and whatever the parameters you need. So your function may need one variable, or you can have more than one variable like x and y, and so on. And then you have a bunch of instructions ending with the end keyword. So this defines the instructions between these two words, define the function itself. Now the def and end are reserved words. That means they cannot be used as variable names, so be careful about that. That's very, very important. Now the name of a method will follow the same rule as the name of the variables. Must start with a lowercase character. The parameter list can contain one or more variables, like you can have one or more variables here. So, and also you can have no parameters like this one. The whole purpose of this function is to write print hello world. And then if you notice that this indicates the new line character, that means after you print it, then write a new line character and move the cursor to the next line. So here's an example of a more complicated function where you're trying to combine the shaded area, the square, the area of the shaded part of this, and this is x over 2, x over 2. So we have compute area, and you're given a side, and then first thing you do is you compute the area of the square, and then you compute the area of the triangle. So here's the area of the triangle, 1/2 times. Notice that you can write 1 over 2, but it's better to, I don't think you should write 1 over 2, because if you write 1 over 2, it would give you 0. As we talked about, 1 over 2 gives you the quotient when you divide 1 by 2. So you have to write 0.5, not 1 over 2. And then you have the area of the triangle, and the area of the of interest is the area of the square minus the area of the triangle. And then we return that area. And so if you load that function, if this function is in a file called countertop.ruby, and then if you compute the 109 with the area side as 109, it'll give you a number. So when some of the terminology we use in programming, to run a method we say we call a method. A method can return either one answer or no answers, so it's called. So like for example, hello world does not return anything. It simply prints something onto the screen. Compute area does return something. For example, it's 109 here. The next concept we want to discuss is called the loop or iteration. Iteration means that you want to execute one or more instructions and you want to repeat that. So let's say that you want to add the numbers 1 through 10, and what you're doing is you're adding numbers, but the numbers change, but the process is the same. You just add the 1, and then you add the 2, then you add the 3, then you add the 4, and so on. So the idea for a loop is that you want to repeat something again and again and again. And in Ruby, the loop syntax, how you express a loop, is given by this. We're going to say for loop variable, so we can say for x in start, let's say 1, to end maybe 10. So the loop body, we can say something like sum equals sum plus I. We'll go over some of those things later on, but the idea would be that we can write a loop to do something repeatedly. So another example would be something like, for x in 1 to 10, do print x. So what that will do is to print the values 1, 2, 3, 4 up to 10. So the loop body is one or more instructions that you will repeat, and in this case the start must be less than or equal to end, and for the loop to repeat, and then the body ends at n minus start plus 1 time. So in other words, if you go from 1 to 10, then you will do this 10 minus 1, which is 9, plus 1. So that's n minus start plus 1. So that's 10 times. So all we have to do is that if you go from 5 to 7, you'll say 7 minus 5 plus 1. That would be 3. So if the start is bigger than the end, so if you say from 3 to 1, then it will not do anything. It'll be skipped. So here's an example of that. So here's a loop that says for I in 1 through 5, dot dot means 1 through 5. You need to have exactly 2 dots here. Do print the hello world with a new line. And so what it does is to print the hello world 5 times. And if I change this to 10, it'll print the hello world 10 times. If I change this to 2, it'll print the hello world 3 times, because 4 times it does 2, 3, 4, 5, so on. So here's another example of that. So we have for I in 1 to 5, print I, and then print the new line. So it's just printing the I. It's not printing hello world, but it prints the I, which is the value of I actually changes. It starts from 1, and then it goes to 2, and it goes to 3, and at the end it goes to 5. So here's another example where we have 1, 2, 3, 5. Now the difference between this and the previous example is that this had a new line character, so it did separate the numbers by a new line. But here we don't have a new line character, so it's going to print the numbers one next to the other. So what you see is 1, 2, 3, 4, 5 without any new line characters. Now if you put a white space, then you will have a white space in between the two numbers. Now assignment is a big part of programming. That means you can have an expression on the left hand side, and it's assigned to, this means it's not the equal sign, it's assigned to a variable on the right hand side. So you can only have, the left hand side, you can only have a variable on the left hand side, an expression on the right hand side. So you can say x is assigned y plus z. So it computes y plus z and assign the value to x. Okay, so you can only have one thing here, but you can have more than one thing on this side. The expression is evaluated, and the result is stored in the variable, and then it will overwrite whatever you had in this variable. So if this says x equals y plus z, the new value of y plus z would be the value of x2. So the assignment works like this: x equals 150, you put 150, but there's nothing in y. So we say y equals x times 10, so y changes to 150 times 10, 1500, but x did not change because x is not on this side. You only change if you are here. So this one changes y again to 1501 because it increases by 1. All right, and x did not change. And then x equals x plus y. Now x changes now, but the y does not change because x is the one that's on the left hand side. So it does add the previous value of x, this one, and the y, 1501 and 150, and give you this number 1651. Now here's another one with the sum. So this one says, well, here's a function called sum, and this is a comment, and it's trying to find the sum of first 3 positive integers. Now what we do is we call the sum equal to 0. That means we call them an initialization. We initialize the sum to 0 to begin with, but there's no I value yet, okay, because we haven't begun yet. Now when you go to the loop, inside the loop, what we do is we take I equals 1, and then we add it to the sum. Now sum is 0, you add 1 to I, sum becomes 1 in iteration 1. Then you go to the iteration 2, I becomes 2. Now the sum, you take the previous sum and add the new I, which is 2, and get the value 3. And then when you go to the next one, the last one, you get the previous one of sum, add the new value of I, and get 6, and that's how it goes. So really, if you run this thing many times, say for example you go from 1 to 20, the sum will give you the sum from 1 to 20. Now keep in mind that the loop, you have initial statement, and then you have a loop, and then you return the final answer as a sum. Now, one thing you want to be sure about is that if you use a variable I as a control variable, do not change it, because if you change it, it will skip the meaning of this. Like usually if I don't have this statement, I will go from 0, 1, 2, 3, 4, 5, 6. But if I do have this, I will start from 0, but it'll jump to 2 next, and then it'll jump to 4, and it'll jump to 6, and so on. Okay? So if you generalize the solution, we can say, now that we know how to find the sum of, say, 3 numbers, how do we find the sum of n numbers, but the n is not known yet. So we want to write a generic function. We say, okay, let's find the sum of first n positive numbers. We have the same code. The logic changes. The only thing is we replace the 3 by n, and we have the same logic and same things. The nice things about this function is that I can reuse this again and again with n equals 6. That means from 1 to 6, or 1 to 100, or 1 to 15, 110. So this is really a lot of very powerful function that can do a lot of interesting things here. Now here's another example of a loop where you have, let's say you want to compute the sick people if you start with n. So it says compute the sick people after n days. So suppose you start with newly sick is 1 and total sick is 1. Now each iteration represents 1 day. Like for example, newly sick would be doubled each iteration, so from 2 to n. And total sick would be the old total sick and the newly sick added to it. So in other words, you double your sick people every single day because you're infecting more and more and more people. So at the end, you're returning total sick. And if you really look at this, it's amazing the size of this number, right? The sick is 1 if you have 1, but if you have 2, it's 3, and then it grows exponentially. In just 3 weeks, over 2 million people are sick. Okay, so if you read the book Blown to Bits, we call that exponential growth. I mean, this function is really exponential. It's amazing. And counting down is also can be done with a loop, but the counting down means the question would be, how do I count down? How do I print from 10 to 1, not from 1 to 10? Then you do a little trick. You still go from 1 to 10, your control variable, but you're printing 11 minus I. So when I equals 1, you'll be printing 10. I equals 2, you'll be printing 9, and so on. And sleep 1 means that it pauses for 1 second. It's kind of like a nice simulation that you can pause and 1 second and prints the next one, and so on. And so that's pretty much what we talked about in the loops.